Okay, Year 7, today we are going to have a look at transversal and parallel lines. Now I know these are both really big words, but that's okay. We are going to clarify exactly what we mean about transversal and parallel, and we're going to talk about how they fit into our topic of angles. So, let's begin. What is a transversal? You need to have a heading in your rule book, transversal and parallel lines. Underneath it, I'd like you to write this heading. What is transversal? Now, that sounds like a really big, tricky, complicated word, but it's not actually. I need you to write this definition underneath it. It says, a transversal, or this big new funny word, is simply a line intersecting two or more other lines. Now, these two other lines are usually, but they're not necessarily always, parallel. Now, what in the earth does Mr. Corsi mean by that? Well, you'll see in the diagram I found a real life example. We have a freeway, a line of a freeway going this way, and we have a line of a freeway going that way. Okay? We have a line cutting through the middle of them or intersecting through the middle of them. This one here, I'll do it in another colour. This line just here intersects through the middle of it. This line here is a transversal. Now, in most of the examples we will look at, these other two lines, this one here and that one there, will be parallel, but they don't necessarily have to be. I just wanted to point that out. Okay? They're not always, but usually they are parallel. So you need to write that down. Obviously, you don't need to draw this, okay? This was just here as an example for you on the video tutorial. Now, I mentioned this word parallel. Hopefully some of you will remember what this means from primary school. If not, I need you to write this down underneath it. It says, what is a parallel line? Okay, so parallel lines aren't too tricky. When I say the word parallel lines, I simply mean lines that are always the same distance apart and that they never touch. So here's an example of it underneath here. I've got the line AB, so I've named it with my capital letters. Okay, and they are always the same distance apart and they never touch. And the idea is that they're going in the same direction. Okay, they go in the same direction. Another example of parallel lines will be just here that I'm drawing on your screen. These are parallel lines, okay? They are always the same distance apart. Here they're the same distance, there they're the same distance, okay? And they never touch. They are always going in a similar, or the same, direction. Now, let me give you an example. You think, oh, isn't that every line? Let's have a look at two lines that are not parallel. So I'll draw this one again, okay, that line. A not parallel line would be a line that went like that. If I continued these lines on, for example, they would eventually touch, which means that these two lines, as an example, are not parallel. So parallel lines are lines that are always the same distance apart and they never touch. Now, we've been looking at identifying angles and doing certain annotations or little drawings on diagrams in order to be able to represent things. Okay, now I can't just draw my lines like this and say, yep, they're parallel. There's something that I put on those lines that helps us know that they're parallel, okay? And they're these little sets of arrows, okay? They look a little bit like this. On the diagram, you see them here and here. What that tells whoever's looking at that diagram is that this line and this line are parallel. This line and this line are parallel, okay? So we represent parallel lines by marking them with the same little arrow sets. So transversal is a line that cuts through two other lines, okay? Those other two lines are usually parallel. Parallel lines are two lines that always are the same distance apart, never touch, and head in the same direction. Okay, now what does all of this mean? A transversal or a transversal line that crosses two other lines will form special pairs of angles, okay? There's different angles that form when a transversal crosses two other lines. Today we're going to look at 3 of those special pairs. That will be alternate, corresponding, and cointerior. We're going to look at 3 of the special types of angles that a transversal creates when it crosses 2 other lines. Okay? What I would like you to write underneath that example of parallel lines is simply this sentence, okay? A transversal crossing 2 lines will form special pairs of angles, Okay? Need you to write that bit down. Today we're going to look at alternate, corresponding, and cointerior. So, let's begin. Corresponding angles, okay? Corresponding angles are equal when a transversal crosses 2 parallel lines. Okay, firstly, let's start back. Let's look at this guy over here, okay? I've got 2 pairs of parallel lines. I've also got a line cutting them through the middle. This guy here is my transversal, okay? When my 2 other lines are parallel, and only if they are parallel, one type of angle that's formed are corresponding. Corresponding angles will be in this corner and this corner. They're not next to each other, they're not beside each other, but they are there and there. Okay, let's look at our other example. I've got 2 parallel lines here. Okay, I've got this parallel line and this parallel line. I know that they're parallel because the little arrow signs tell me they have the same number of arrows on each. I have a line going down the middle here. This is again my transversal, okay? The corresponding angles are here and here. They are corresponding. The thing to remember is if they are corresponding, it means they are equal. So this angle is equal to that angle. They are the same size. They are equal. Corresponding angles are equal when the transversal or the middle cutting line crosses 2 parallel lines. Alternative angles are also equal when a transversal crosses 2 parallel lines. So, parallel line 1, parallel line 2. We know they're parallel because they have the arrows. I have a transversal that cuts through the middle. This angle and this angle are alternate. They are alternate angles, okay? So here and here. And when that transversal crosses between those 2 parallel lines, that angle is equal to this angle. Let's look at another example over here. I've got a line going up here and a line going up here. These are parallel lines. I know because they're marked as such. I have a line cutting down the middle. That's my transversal, okay? Which means that this angle and this angle are alternate. And being alternate angles on a transversal that has 2 parallel lines, they're equal. They are equal. This angle is equal to this angle. Let's look at our last example. Cointerior angles are the last type of special angles that are formed when a transversal crosses 2 parallel lines. Cointerior angles add up to 180 degrees. They only add up to 180 degrees when our transversal, our cutting line, cuts through 2 parallel lines. Now, what are the cointerior angles? Okay, the cointerior angles are this angle here and this angle here. The interior or the cointerior. This angle here and this angle here. They are both cointerior. The sum of those 2 angles, So this one plus this one will equal 180. Just like this one plus this one will equal 180. Okay? Cointerior angles add up to 180 when two parallel lines are crossed by a transversal. So that's a wealth of information, guys. I've just flooded you with so much information. So let's have a little bit of a look at what I mean by it. Let's have a look at this example here. It says, name the angle that is corresponding to angle ABF. So let's name the angle that is corresponding to ABF. So if I get my pen out here, I see that ABF is here. Okay, ABF is this one in here. That's my angle. Where's the angle that is corresponding to that? Okay, so if I remember corresponding, that must mean that this spot here, this angle here is corresponding. That angle is angle DFG. So, the corresponding angle to ABF is angle HFG. Let's look and see if we can find the alternate angle to angle ABF. So again, angle ABF is in there. Where's its alternate angle? That's the one on the other side. That's this one here, isn't it? What angle is that? Okay, and if I look at the 3 points, it's angle EFB. So the angle alternate to angle ABF becomes angle EFB. Just lost this one in here. Okay, so let's have a look at the next one. Angle cointerior to ABF. Now I'm not going to draw the line again. ABF is this angle in here. I need to find the angle cointerior. That will be this one in here. So that will be angle HFB. Angle HFB. Now, I've thrown in question D here. It says, which angle is vertically opposite to angle ABF? And I'm going to leave that one for you to do. You might want to write that, pause the video tutorial here and see if you can work it out. If not, what I would like you guys to do is I'd like you to draw this diagram. I'd like you to write the questions and I'd like you to fill in the answers where I filled them in. Okay? So you need to write this down as an example. Okay, our question here says, find the value of A in these diagrams and give a reason for each of the values that you've given it. Oh, bother. Okay, let's have a look at what this might mean. I've got a question, okay? I've got a diagram and it has 55 degrees and then A degrees. Now my angle that is marked here, I've got one here and one here. I've noticed that there's parallel lines and there's a transversal cutting between it. Now I just learned of a rule. I learned that when angles are corresponding or in corresponding positions like this and the transversal is cutting between parallel lines, they must be equal. Okay, so my answer to A would be A equals 55 degrees because corresponding angles are equal in parallel lines. Okay, so the question has asked me to find A. A is in a corresponding position to this angle here. These angles are corresponding. I see that I have parallel lines and I know that corresponding angles amongst parallel lines are equal. Now please, I would like you to write EQUAL, not just an equal sign. I was just running out of room. But That should hopefully answer that question. Let's look at the next one. It says find the value of A again and give a reason. This one's different. They're not in corresponding positions. If it was in a corresponding position, it'd be down here. So it can't be a corresponding angle. Oh, that's right. If they're in alternative positions, like here to here, that means they're also equal. That's an alternative position that they're in. So, my answer, A, becomes 115 because I know alternative. Oh, Mr. Corsi spelled that wrong. Oops, and she can't delete it. Alternative angles in parallel lines, I'm just going to abbreviate that PL, are equal. Okay, so I know that they're equal because I've got two parallel lines and a transversal, and this one and this one are alternate. And when all those things are the case, alternate angles are equal. This is 115, therefore this is 115. Let's look at our very last example. Okay, our very last example says, find the value of A in these diagrams and give a reason. I've got two parallel lines. I've got a transversal. Now this time I've got my angle markings, and this one has 2 and that one has 1. So if I think back to last lesson, I know that reminds me that the size of this angle will be different to the size of that angle. Okay, that's kind of helpful. Is there a special relationship between each of them? I remember. Cointerior angles add up to 180. Cointerior, or on the inside. This one is on the inside of the parallel lines, and this one is on the inside of the parallel lines where the transversal cuts. They almost form a C. C for cointerior, okay? And they add up to 180. So if I've already got one that's 110, okay, the other one must be 180, subtract 110, which equals 70 degrees. Why does it equal 70 degrees? Because cointerior angles add to 180. Remember, they only have a special relationship, so they only add up to 180 when my lines are parallel. And that's it, guys. That's all of the examples.